This is SpaceTime Series 25, Episode 130. Are the Sun's solar cycles getting weaker? Claims that Mars was once covered by 300-metre deep oceans, and another scrub for southern launch. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
New computer modelling suggests the Sun's 11-year solar cycle appears to be getting weaker, and scientists aren't sure how that's going to affect the Earth. Our local star has just come out of a fairly weak solar minimum, and it's now building up to a new solar max for solar cycle 25. That'll see increases in sunspot activity and with it more solar flares and coronal mass ejections, the geomagnetic events causing space weather on Earth. However, new computational data based on space observations suggests the long-term trend is for overall weaker solar cycles. When energy from solar flares or matter from coronal mass ejections hits the Earth, they cause our planet's protective magnetic field to quite literally wobble, sort of like a jellyfish. If the event's powerful enough, ionized matter penetrates the magnetic field. It then travels along the planet's magnetic field lines deep into the atmosphere. And these trigger spectacular light displays in higher latitudes, the famous northern and southern lights, the aurora borealis and aurora australis. But they also damage and can even destroy delicate electronics on spacecraft. They affect communications and navigation systems. They trigger power blackouts on the Earth, and they increase radiation doses for astronauts in space and even people flying in high-altitude aircraft. Less geomagnetic storm activity should mean less of these events. But it also means there's less increases in the strength of the solar wind, the constant flow of charged particles streaming out from the Sun, and the solar wind acts as a buffer, preventing cosmic rays from deep space reaching the inner solar system and the Earth. The Sun is much more than just a source of light for planet Earth. It's a dynamic and complex star, with storms, flares, and movements causing it to constantly change. Magnetic fields govern most of the solar activity. And while astronomers can observe how they do this, it's still poorly understood. The new computer simulations are coming out of NASA's Advanced Supercomputing Facility at the agency's Ames Research Center in California's Silicon Valley. And they're painting a more complete picture of one of the most prominent magnetically driven solar features, a cycle of sunspot formation known as torsional oscillation. The data for this computational analysis came from observations by two NASA spacecraft, SOHO, the Solar and Heliospheric Observatory, and the SDO, the Solar Dynamics Observatory. It's revealed that the strength of these torsional oscillations driven by the Sun's magnetic fields deep inside the Sun are continuing to decline. This indicates that the current sunspot cycle may end up being even weaker than the previous one that was already considered fairly weak. It also means the long-term trend of declining magnetic fields in the Sun is likely to continue. These changes in the Sun's interior could have impacts on space weather and the Earth's atmosphere and climate. The sunspot cycle begins when a sunspot starts to form, usually at around 30 degrees latitude on the Sun's surface. The formation zone then begins to slowly migrate towards the equator. At its peak intensity, the Sun's global magnetic field reverses polarity. It's as if the positive and negative ends of a magnet were suddenly switched. Now, these cycles occur over a 22-year variation, and they're caused by dynamo processes inside the Sun. A dynamo process is when rotating convecting and electrically conducting fluids or plasmas help maintain a magnetic field. These deep magnetic fields are hidden and can't be observed directly, but their effects can be seen in variations of solar rotation, creating a cyclical pattern of migration across zones known as torsional oscillations. In some areas, this rotation speeds up or slows down, while in others it remains steady. The Joint Science Operations Center at California Stanford University processed data from 22 years of solar observations. That's more than 5 petabytes in total. And NASA's supercomputing facilities at Ames handled flow analysis, numerical modeling, and visualization, giving scientists a better look at this complex pattern. Going forward, improvements in the data's resolution, as well as data analysis techniques and simulation models, will help merge models of the Sun's magnetic field with those of sunspot activity, thereby advancing science's understanding of how these processes impact the Sun's deep interior. And that's important because what happens in the Sun, including processes beneath its surface, affects space weather, which impacts the entire solar system. And that, of course, includes the Earth. This is SpaceTime. Still to come, a new NASA climate change mission ready to launch, and a new study claims Mars was once covered by 300-metre deep oceans. All that and more still to come on SpaceTime. The countdown's underway as NASA's greenlighted a launch on December the 12th for its Surface, Water and Ocean Topography or SWOT spacecraft. The 2,000-kilogram satellite will fly aboard a Falcon 9 rocket from the Vandenberg Space Force Base in California, providing high-definition data on salt and freshwater resources right across the Earth's surface. The mission is a collaborative effort between NASA, the French space agency CNES, with contributions also from the Canadian and UK space agencies. Covering more than 90% of the Earth, SWOT will survey nearly all the water on the Earth's surface for the first time, measuring the height of water both in Earth's freshwater bodies and oceans, and providing insights into how oceans influence climate change, how a warming world will affect lakes, rivers and reservoirs, and how communities can better prepare for disasters like floods. Water plays a crucial role in storing and moving much of the excess heat and carbon trapped in Earth's atmosphere by greenhouse gases. And of course, it also influences weather and climate. So by tracking the Earth's water budget, where the water is today, where it's coming from and where it's going to be tomorrow, scientists will have a better understanding of how water resources are changing, what impact those changes will have on local environments, and how the oceans react to and influence climate change. While past satellite missions, like Topex's Poseidon and the Jason's 1, 2 and 3 series satellites, have provided variation in river and lake water surface elevations at select locations, SWOT will provide the first truly global observations of changing water levels, stream slopes, and inundation extents in rivers, lakes and floodplains. In the world's oceans, SWOT will observe ocean circulation at unprecedented scales of 5 to 25 kilometres. Approximately an order of magnitude better than current satellites. SWOT operates at Ka-band's relatively short wavelengths compared to the Ku-band Jason series. That means higher fidelity. The satellite will fly 2 radar antennas at either end of a 10-metre mast, allowing it to measure elevation of the surface across a 120-kilometre wide path. In fact, this new radar system is similar but smaller to one which flew on NASA's Space Shuttle radar topography mission, which made high-resolution measurements of Earth's land surface in the year 2000. It means SWOT will see Earth's water at higher definition than ever before, and with unprecedented clarity. A conventional nadar radar altimeter will also be flown, measuring just beneath the satellite, as was done on the Topex's Poseidon and Jason series. Scientists believe that Earth's oceans have absorbed more than 90% of the excess heat trapped in the atmosphere and caused by human greenhouse gas emissions. And that's why SWOT will help scientists' understanding of oceans' role in climate change. SWOT will also provide crucial information about this global ocean atmospheric heat exchange, enabling researchers to test and improve climate forecasts and help fill gaps in researchers' picture of how sea levels are changing. And of course, climate change is also accelerating Earth's water cycle, leading to more volatile precipitation patterns, including more torrential downpours and extreme droughts. As we're seeing in Australia, some communities are already experiencing increased floods, so SWOT's data will be used to both monitor drought conditions and improve flooding forecasts for rivers. This report from NASA TV.
So for me, SWOT is water. SWOT is precision.
In one word, I would describe SWOT as beautiful.
SWOT stands for Surface, Water, and Ocean Topography.
SWOT will be observing the elevation of water surface in the ocean, on the land. The water surface height will allow us to assess the water storage in lakes and stream flow of rivers.
Our water is one of our precious resources. SWOT is unique because it is the first global view of our ever-changing water supply on Earth.
SWOT's main instrument is called KERN, which is the Ka-band radar interferometer. Cairn is what sets apart SWOT from other missions. It's a unique instrument that we're flying for the first time.
The Cairn instrument uses the two antennas, which are spread out on either side of the spacecraft, in order to bounce signals off of both of those to get a much larger view of the surface.
And being able to do it in very high resolution, higher accuracy, and also a wide swath so that we're able to measure large tracts over the Earth in a relatively small amount of time.
SWOT is a pathfinder mission using new technology to address transformative questions on climate change and its impact on our environment.
We're collaborating with CNES, the French space agency, for these programs, but we're also helping the global community to be able to contribute and collaborate towards making our home planet a better place.
SWOT will make our models better, and understanding the water budget helps us be able to steward that precious resource.
If water is out of balance, we could face droughts, and it could also lead to floods.
SWOT is going to be observing water in oceans, and ocean science is essential for understanding sea level rise and climate change.
Now we are facing a time that we need to be very precise. Therefore, we can accurately predict what will happen in our coastal cities 50 years from now.
Understanding that it is a finite source and we can't rely on that forever is something that's really important.
I'm just so excited and can't wait to see how it impacts the lives of others.
Without really understanding the Earth, we cannot protect it, because we know that the missions that we work on are going to have an impact on our children and our grandchildren.
And in that report from NASA TV, we heard from SWOT project scientist Li Leung Fu, SWOT mechanical engineer Phoebe Rhodes-Wickett, Karen systems engineer Eva Pearl, and SWOT project manager Parang Vase. This is SpaceTime. Still to come. A new study claims the red planet Mars was once blue and covered in 300-metre deep oceans. Another scrub for southern launch, and it's planned to begin space operations from South Australia. And later in the science report, researchers sequenced the genome of Australia's floral emblem, the golden wattle. All that and more still to come on SpaceTime. A new study claims that the red planet Mars was once blue and covered in 300-metre deep oceans. There's clear evidence today that Mars was once a warm, wet world with lakes, rivers and oceans. But just how much water was on Mars is still hotly debated. Now, a new study reported in the journal Science Advances suggests that some 4.5 billion years ago, there was enough water for the entire planet to be covered in a 300-metre deep ocean. The study's author, Martin Bizarro from the University of Copenhagen, says that during this time, Mars was bombarded by asteroids filled with ice. He says it happened during the first 100 million years of the planet's evolution. And these same asteroids also carried organic molecules, including amino acids. Amino acids are important for life. They're used when DNA and RNA form bases and contain everything a cell needs. Bizarro says this means that Mars probably had conditions conducive to life long before they existed on planet Earth. His research indicates that the oceans that covered the entire red planet in water were at least 300 metres deep and may have been up to 1 kilometre deep in some places. Now, by comparison, Bizarro says there was actually very little water on Earth. His conclusions are based on a Martian meteorite billions of years old, which has provided a glimpse into the red planet's early history. That meteorite was once part of the Martian crust, ejected into space as part of debris when an asteroid slammed into the planet. The meteorite, therefore, offers a unique insight into what happened at a time when the solar system was still forming 4.6 billion years ago. Bizarro says his hypotheses are based on one key fact: the way the Martian surface has remained relatively unchanged, and so the meteorite acts as a time capsule providing a snapshot of the early Martian crust. You see, Mars never experienced the constant resurfacing the Earth undergoes because of tectonic plate movements, which are perpetually recycling the Earth's crust into its mantle. Put simply, plate tectonics on Earth have erased all evidence of what happened to this planet during its first 500 million years of history. By contrast, Mars doesn't have plate tectonics, and therefore the planet's surface preserves a record of the very early history of the red planet. Bizarro also points out that about 100 million years after the proto-Earth formation 4.6 billion years ago, it was struck by a Mars-sized planet called Theia, which then turned the early Earth into a molten magma ocean, in the process creating the Moon. Bizarro says this collision would have wiped out any potential early life on Earth. Therefore, there's really strong evidence that conditions allowing the emergence of life were present on the red planet Mars long before they existed on Earth. Storm damage has delayed the launch of ATSpace's Kestrel 1 rocket from Southern Launch's Whalers Way Space Complex near Port Lincoln. Severe thunderstorms hit the Eyre Peninsula launch pad in South Australia, bringing high winds, heavy rains, and an unprecedented 420,000-plus lightning strikes. The tempest caused significant damage to the launch vehicle, and mission managers say electrical faults will require off-site repairs. ATSpace are planning 2 suborbital flights for its Kestrel 1 rocket. The VSO-2 and VSO-3 missions will fly on different trajectories to test local operating conditions over the skies of the Great Southern Ocean. The experimental Kestrel 1 is designed to develop and test technologies which will eventually be used in the Kestrel 5 orbital launch vehicle. This has been the 4th mission scrub from the privately operated Southern Launch Facility. Severe weather conditions have now been responsible for 2 cancelled launches. A 3rd launch was halted due to a systems failure, and the very first launch attempt was scrubbed when a South Korean Hapeth-1 rocket caught fire on the launch pad. This is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.